Hello friends, my name is Ritupriya Pandey and today I'll be teaching you about the topic planetary winds. But before moving towards the topic, here's my introduction in a very nutshell. My name is Ritupriya Pandey. I have done my graduation in BSc Honours Biotech and I'm a silver medalist here. I have done my post-graduation in microbiology as well as geography. I have two post-graduation. And I have experience of teaching to UPSC aspirants of more than 14 months for the subject geography as well as biology. Okay, now let's get started. First of all, you must have heard so many songs like क्यों चलती है पवन और सावन का महीना पवन करे शोर, and you must have questioned to yourself in your mind, या literally हवा क्यों चलती है, किस डायरेक्शन में चलती है, हमें कैसे पता चलता है, IMD वाले कैसे बताते हैं कि यार हवा इतनी तेज चलने वाली है या फिर ये होने वाला कुछ भी. What is the mechanism behind each and everything of the wind? Today you are going to get all the answers of your questions, okay, which you have asked to yourself or to someone else also earlier. Now you are going to get started. Here, let me ask you one more thing. What is the basic difference between the air and the wind? Air is the stable form, okay? And when air comes in the motion, it's known as the wind. Wind blows from high pressure to the low pressure area because there is one more thing. There is a concept of pressure gradient. Whenever there is the difference between the two atmospheric pressure, it's known as pressure gradient, and wind blows from high pressure belt towards the low pressure belt. Okay, so this is about the wind, and there are three different types of wind. First is known as primary wind, also known as planetary wind, permanent wind, or global winds. Okay, and why are they named so? So means planetary wind or permanent wind or global wind, because they are found all over the earth. All over the earth means our planet. Okay, they are permanent because they are found at a particular latitude with a constant speed in a constant direction almost throughout the year. That's why they are permanent. And global obviously because they are found all over the globe. Okay. Second is our secondary wind, also known as seasonal winds, like monsoon. Like in India today, monsoon season is going on. So monsoonal winds are blowing everywhere and you must be feeling that it's very warm and it's very pleasing, it's very nice. Third is the tertiary wind, also known as local wind, like Loo of India, Chinook of USA, Mistral of Egypt. You can easily connect to the term Loo. Loo is found in the area of Uttar Pradesh, Bihar and some other parts of the northern India, but not in southern India because they are very warm wind. Okay, they are found at a particular location. That's why they are known as the local wind. Okay, now here it comes the slide. The latitudinal winds which blow throughout the year in almost same direction are called as planetary winds. And why are they named so? I have told you. Now there are three different types of the planetary winds. First is the trade wind, also known as easterlies. Second is the westerlies winds, and third is the polar easterlies winds. But before going towards the detail of all these types of winds, let me show you a diagram of pressure belts. Here you can see we have 7 different types of pressure belts. At 0 degree latitude, we have equatorial low pressure belt, also known as doldrums. And why is it known as doldrum? I will tell you. And at 30 to 30 degree north, we have subtropical high pressure belt or horse latitudes. Later on, I will tell you the reason behind why it's known as horse latitude. Then at 60 degree north, we have subpolar low pressure belt. And at 90 degree, we have polar high pressure belt. And whatever goes on in the northern hemisphere, same goes on for the southern hemisphere also. But there is one small difference, or you can say there is one difference between the northern hemisphere and the southern hemisphere when it comes to westerlies. And I'll be telling you about that when the topic westerlies will come. Okay. Now the trade wind or the easterlies. Why are they named trade? Trade means business. So why are they called as trade, not anything else? Like the winds are named according to the direction from which they are originating. But they are known as trade means business wind. Actually, they are very calm wind. They flow at a particular latitude throughout the year in almost same direction with a constant speed. Okay. So in ancient time, it helped the sailors to sail their ship according to that particular direction with that particular speed and to reach their final destination to do the business. That's why they are known as trade winds and they are very reliable winds. Nowadays, different techniques have also come, but in ancient times, sailors used to sail their ship according to this trade wind, and that's why they named it as trade winds. Okay. Now here you can see the diagram. We have three different types of cells. One is known as headless cell, other is Ferrel cell, and next one is polar cell. I'll be telling you about all these different types of cell, but firstly it's headless cell. Headless cell, it is found in the latitude, like they are found between the latitude of 30 degree north to 0 degree equatorial, and same for 30 degrees south to 0 degree equatorial for the southern hemisphere. Okay. So what happens here, as we all know, this is equator. Suppose this is equator and sun is just overhead of the equator. So when sun is overhead of this equator becomes warm. So the wind blowing above the surface of the equator, it also becomes warm. And as it becomes warm, it becomes lighter and it rises up. And there is one more thing, as you all know, with increase in distance, the temperature decreases. Okay, so this warm wind, when it rises up, it reaches up till the troposphere, and with increase in temperature, with increase in distance, the temperature decreases. Okay, and then it gets deflected towards the polar side. So what happens here? When it gets deflected towards the polar side, it becomes more and more cooler, denser and heavier. And due to this, at 30 degree latitude, it starts sinking over there. And if it starts sinking over there, that means high pressure belt is created over there. Okay, so it starts sinking at 30 degree north. And from 30 degree north, what happens, as I have already told you, wind blows from high pressure belt towards the low pressure belt. So wind starts moving from high pressure, subtropical high pressure belt towards the equatorial low pressure belt. Okay, because there is a gap. Suppose wind is rising up, so there is a gap created over here. So to fill that gap, the wind from the high pressure belt moves towards the low pressure belt. Okay, and this cycle continues and goes on in the headless cell at the latitude of 0 degree to 30 degree in the north as well as in the south. Okay, so this is known as headless cell because cycle is going on. It's very normal over here. Then you can see the direction of the wind in the northern hemisphere. What happens? You must have thought, when wind is coming like this at equator, then why it's not coming straight towards the equator? Why it's getting deflected towards any other direction? It's just because of one reason, that is known as Coriolis force. Coriolis force is nothing but a false force, and about this I'll be telling you later on this chapter. Okay. So what happens? When the wind blows from northern hemisphere or northern side in the direction of the wind, due to Coriolis force, it gets deflected towards the right side, and in southern hemisphere it gets deflected towards the left side due to Coriolis force. Okay, but you can also see one more thing. There is a narrow belt over here. Okay, here winds are moving like this at equator. They are not colliding with each other. Suppose the winds is coming from northern hemisphere and other wind is coming from southern hemisphere. They are coming towards each other, but instead of getting collided, they are rising up like this. They do not collide. They do not mix up at equator. It's just because there is a very narrow belt of width around 1 to 5 degree, both in the northern as well as southern hemisphere, and this narrow belt is known as doldrums. Doldrum is also known as intertropical convergence zone. Okay, so what happens, since they are moving towards each other, they come over here. They are of same speed, same nature, so they do not collide with each other. Okay, they converge here and they rise up. Then they flow towards the polar side at 30 degree latitude, both in north and south. They start sinking and then they start blowing from high pressure area to the low pressure area, or high pressure belt towards the low pressure belt. Okay. And there is one more thing, or one more term I told you, intertropical convergence zones. Okay, what happens here? Suppose this is equator. Sun is just overhead. When the sun is just overhead of the equator, then this is the normal situation which you are seeing on your screen. But if the sun start moving towards upward towards the Tropic of Cancer, then due to this low pressure belt created at equator region, it also starts moving upward. Okay, and when the sun comes to its regular position, this equatorial low pressure belt also comes to its regular position. Okay, and this is for intertropical convergence zones area. Okay, so now you can see here they are more consistent winds. Their direction and speed don't change much across the season. That's why they are used for trade. They flow in headless cell, I have told you, in both the hemispheres, that is from subtropical high pressure belt to equatorial low pressure belt between 30° north and 30° south latitudes. They flow towards the equator from northeast in northern hemisphere and from southeast in southern hemisphere because of the Coriolis force. Coriolis force deflect the wind towards right in the northern hemisphere and towards the left in the southern hemisphere. Because the trade winds are consistent and relatively smoother winds, they do not mix at the equator, as I told you earlier. They come towards the equator, they get warm, moist and rise up along a very narrow belt known as doldrums. Doldrums are formed only on ocean, not on land. This is the important topic which you can mark also. Doldrums are formed only on ocean, not on land. Doldrums also known as intertropical convergence zones, and pressure belts depend upon the overhead sun. I have explained you each and everything, why this is moving upward along with the sun, why it's coming back to its regular position because of the sun. Okay. If sun moves upward towards the Tropic of Cancer, then equatorial low pressure belt also moves upward. The trade winds descend and remain stable at their origin, that is subtropical high pressure belt. I have told you this, that wind at 30° north or Hall's latitude, they start moving from 30° north towards 0° or high pressure towards low pressure. Now it's westerlies. Second is westerlies. Why are they named so? Because they start moving or from west side, means they are originating at the west side. That's why they are named so, westerlies. Okay. And here I have shown you one more diagram, that we have cell, and second one is a ferrule cell, both in northern hemisphere as well as in southern hemisphere, and I'll be explaining you each and everything about the northern hemisphere. You can easily correlate it with the southern hemisphere also. Okay. So ferrule cell, it is found between the latitude of 30° north to 60° north. Okay. What happens here? If wind starts moving from first west side, it's originating in the western side, so it's known as westerlies, and it start moving from high pressure belt towards subpolar low pressure belt. Okay, so it's start moving like this. Suppose this is the western side and this is the high pressure area, this is low pressure area. So wind start moving from west side of the high pressure area towards the low pressure belt or polar low pressure area. Okay. So this is the direction of the wind. Westerlies are moving like this. And why it happens? Because as you all know, that at subpolar region, low pressure area is maintained or low pressure latitude is over there, due to which the wind is rising up, and it's rising up like this and it's getting deflected towards polar region. Okay, and to fill that gap created by the low pressure area, the wind from the westerlies of subtropical high pressure area, they blow towards the low pressure area. Okay, and this cycle continues like headless cell. This cycle also continues in the ferrule cell and from the western side. That's why it's known as westerlies. Okay, so here you can see they flow in the ferrule cell 30° north to 60° north in northern hemisphere and same in the southern hemisphere. They flow from subtropical high pressure belt towards subpolar low pressure belt in both the hemisphere. Their direction. Okay, Here you can see that they are originating from southwest to north in the northern hemisphere. Here you can see they are moving from southeast towards the northwest in the northern hemisphere and from northwest to southeast in the southern hemisphere, and because of one region, Coriolis Force. Okay. Yeah, I have told you one thing earlier in this topic, that there is only one difference, and that comes in westerlies. That, as you all know, northern hemisphere. Most of our continents and landforms, they are found in the northern hemisphere, and in southern hemisphere only few continents are there, like Australia, Antarctica, some part of the South America, some part of the Africa. So southern hemisphere is dominated by the ocean area. Okay, there is no hindrance, or there is no landform as a hindrance in the path of the southern westerlies. So what happens here? They become very strong because there is no hindrance, so they blow with a very high speed in the southern ocean. Okay, what happens here? Okay, at different latitudes, they come with different speed and they make different noises, due to which they are named differently. For example, here you can see roaring 40s. Roaring 40s means they are blowing at between the latitude of 40 degrees south to 50 degrees south. Now their speed is increasing and they are becoming more and more furious. So they are named as furious 50s. Furious 50s means they are moving between the latitude of 50 degrees south to 60 degrees south. Now their speed is becoming more and more high and they are sounding like someone is screaming. That's why they are named as screaming 60s. And they start moving at the latitude between 60 degrees south to 70 degrees south. Okay. So this is that, the direction of the wind, the origin of the wind, and why they are named differently in the southern hemisphere, because there is no hindrance, there is no landform, so their speed increases at different latitudes, and according to that they are named differently. So this is all about the westerlies. Now moving towards polar easterlies. Polar easterlies means polar region, they are found in the polar region, that's why they are named as polar, and easterlies because they are originating in the eastern side, that's why they are named as polar easterlies. Okay, and since they are originating in the polar region, that's why they are very cold, obviously. So they are very cold over here and they are moving in the eastern, from the eastern side, so that's why they are known as easterlies. Now they are dynamically induced low pressure region. Okay, what happens here? So here you can see at 90 degree latitude, air is sinking. Air is sinking means high pressure belt is created over there. And below that, it's low pressure belt, subpolar low pressure belt over here. So they are dynamically induced because they are moving in the polar cell. Yeah, I have told you there are three types of cell. Last one, for the polar easterlies, we have polar cell. Cell means cycle. Okay, what happens here? The wind from high pressure area move towards the low pressure area, and the wind of low pressure area, they start rising up. They move towards the pole. They sink at 90 degree, and at 90 degree high pressure area is created, and from high pressure the wind starts moving towards the low pressure area in the polar region also. So this is known as polar cell for the polar easterlies. Okay, and its latitude is 60 degree north to 90 degree north. Okay, and same for the southern hemisphere also. Here now you can see they blow in the polar cell from polar high pressure belt towards subpolar low pressure belt. Okay, and they are found in the area 90 degree north to 60 degree north in the northern hemisphere, 90 degrees south to 60 degrees south in the southern hemisphere. Now the direction. Here you can see in diagram that wind starts moving from northeast to southwest in the northern hemisphere. Obviously east, they are originating from east side, that's why, and they are in northern hemisphere, that's why they are known as northeast. They are originating from the northern hemisphere, so north. They are originating in the eastern side, that's why east. So they are moving from northeast region towards the southwest in the in the northern hemisphere, and towards southeast to northwest in the southern hemisphere. Okay, So this is all about the polar easterlies. Now we have three different types of planetary winds: trade wind or easterlies winds, second is westerlies wind, and third is the polar easterlies wind. Trade wind, they are found in Hadley cell, 30° north, 0° latitude. Okay, same for the southern hemisphere. Westerlies, they are found in Ferrel cell, 30° north to 60° north in northern hemisphere, and the same latitude for southern hemisphere. Then polar easterlies, 60° north to 90° north in northern hemisphere, and same for the southern hemisphere. Now the most important topic, it's not the last but it's the most important, because this is the only thing which deflects the wind, and we know that this is the direction of the wind, this is the direction of the wind. But why it's like that? Because of the Coriolis force. Coriolis force is also known as false force. It is formed due to the rotation of the rotation of the earth and the relative velocity of the earth. So here what you say, this is the earth and it's rotating from west to east. You can have your own west to east, because obviously you will have your different direction, I will have my different direction because of the screen. Okay, so earth starts rotating from west to east, and at equator its relative velocity is really very high, at approximately 1600 km/h. Okay, so the relative velocity of earth at equator is maximum and is about 1600 km/h. So it's rotating very fast over here from west to east. It's rotating very fast. So whenever any object comes towards the equator, let it from northern hemisphere or southern hemisphere, from anywhere, okay, so it couldn't match the speed of the earth at equator, because the velocity of the earth at equator is really very fast. So instead of falling straight towards the equator, it gets deflected towards the right in the northern hemisphere, because it couldn't match the speed of the earth at equator because of the high relative velocity. Velocity means speed and direction. Okay, speed is very fast, direction is west to east. Okay, so it couldn't match the velocity of the earth at equator. So instead of falling right like perpendicular, it gets deflected towards the right in the northern hemisphere, and same, instead of getting straight on the equator, it gets deflected towards the left in southern hemisphere. Okay, now you got your answer why the wind is getting deflected due to Coriolis force. Coriolis force is nothing but a false force. It is generated due to the rotation of the earth as well as due to the relative velocity of the earth, which is at equator maximum 1600 km/h. Okay, Coriolis force is 0 or minimum at equator and it is maximum at the poles. Okay, and it is determined by the mass of the objects and objects' rates of rotation, as I have told you earlier, that anything, let it be wind or any object, if it's coming towards the equator, it couldn't match the velocity of the earth at equator. So instead of falling straight on the equator, it gets deflected towards the right in northern hemisphere and towards the left in the southern hemisphere. It acts in north and south direction. Okay, I have explained you each and everything. Now I hope I have answered all the questions which you have generated in your mind. Okay, so if you like my video, my teaching, please like and share. Okay, thank you.